Good morning, grade 9 students, and today we will have another new topic, and it's about the difference of series and parallel circuit. For our intention objective, by the end of this lesson, you will be able to draw diagrams and assemble series and parallel circuits, correctly incorporating a switch, battery, loads, resistors, ammeter, and voltmeter. Think about it. There are old Christmas lights that when one bulb gets busted, all lights won't work. Why does one broken bulb shuts the whole Christmas light? But now, modern Christmas lights work even with missing bulbs or busted bulbs. How is it different from the old ones? It's all about the arrangement of the wires and the loads. Today, let's study about the two types of circuit, series and parallel circuits. Are you ready? For our initial activity, we will be having unlocking of difficulties. First, a control component that connects or disconnects the conductive path, allowing or stopping the flow of electricity. So the answer is switch. You turn it on, you can turn it off. The parts that use the energy, like bulbs. The answer is load or loads, like the bulbs, resistors. Next, it measures current. It must be placed in the path or series. So the answer is ammeter. Next, it measures voltage. It must hug the load from the outside or connected in a parallel connection. So the answer is voltmeter. And now for learning experience, we will be having an activity. The title is the Circuit Architect Challenge. Are you ready? You will be given two tasks. And the task 1 is to assemble a simple circuit with two bulbs that when switched on, the two bulbs light up, and when the switch is off, the two bulbs also turn off. So let's start first building our circuit by placing the connecting wires. So the connecting wires are important because this serves as conductive path for electrons so it can travel. Next, let us place our batteries. So the battery provides the enough voltage so that the electrons can move freely in our circuit. Next, let us place the switch. So the switch can turn on and turn off our circuit. And now let's put our load, or in this case, the bulb. So there you go. We turned our switch and the electrons flowed. When the electrons flowed, it provided energy so that the bulb can light up. Okay, so there you go. We successfully created a circuit that makes the light bulb light up when the switch is on, and then the two bulbs also switch off when the switch is turned off. Guide question number 1. What happens to the bulbs? Second questions. What happens if one bulb is removed? Third question. Describe the brightness of the bulb. So for our answer key, number 1, the two bulbs lit when switched on. Number 2, when one bulb is removed, the other bulb does not lit. Number 3, the brightness of the bulb is dim. Task 2, assemble a simple circuit with two bulbs that when switched on, the two bulbs light up, and when the switch is off, the other bulb still lights up. And so again, we will use our application, the PET Colorado simulation. So again, we will start with our connecting wires. After putting the connecting wires, we will place the battery that provides the voltage. So in making this circuit, we will make an alternative route for the electrons. Okay, for guide questions, what happens when it was switched off? Number 2, are the bulbs still lit? Number 3, compare the brightness with the other circuit you built. And for answer key number 1, when switched off, the other bulbs still lit. That is because the electrons have other path that they can travel to. Next, the answer is yes, the bulbs still lit. Number 3, this circuit glows brighter compared to the first circuit. And now from our activity, we learned that first is series connection. In a series circuit, all components are connected in one continuous loop. If one bulb is removed or busted, all bulbs go out. And so for series circuit, the voltage is divided among components. So as you look from our video, we have a voltmeter and ammeter that measures the current. As you point the voltmeter to the different locations in the circuit, it registers different measures. Sometimes it measures 18 volts and sometimes it measures 11.08 volts and sometimes it measures 18 volts, while the current 0.69 does not change. So the current remains the same. It flows through all components. And the total resistance increases when more resistors are added. And that's the reason why it is dimmer when we use two bulbs in the first circuit. Application of series circuit, it is used when all components need to operate together in a single path. For example, flashlights. Second, our old Christmas lights. Number 3, simple electronic toys. This time, it's about the parallel circuit. So in a parallel circuit, components are connected in a separate branches. So when we have separate branches, you offer electrons a different path that they can travel. If one bulb failed to work, other bulbs will still light because the electrons have other path to take. So current splits among branches. So the current is not always constant in parallel. So the same voltage across each branch. So in parallel circuit, the voltage does not change. It is always constant. As you look at the video, when you point the voltmeter at different points in our circuit, it always registers the same voltage. And the total resistance decreases when more branches are added. That's why even though there are two bulbs in the second circuit that we constructed, it is a lot brighter compared to the series circuit. So application of parallel circuit. A parallel circuit is used when devices need to work independently. For example, household electrical wiring. So in our homes, the circuit is parallel. So imagine if our house is connected in a series circuit, when one of the appliances does not work, all of the other appliances won't work. Second, it is used in power outlets. And third, it is used for car electrical systems. And now let's have an activity to test if you understood our lesson. Tell whether it is series or parallel circuit. Number 1. There is only one path for electrical current. Second, if one bulb burns out, the other bulbs still light up. Number 3. It is commonly used in household wiring. Number 4. The current has multiple paths to flow. Number 5. If one bulb is removed, all the bulbs go out. Number 6. The same current flows through all components. Number 7. Each branch receives the same voltage from the source. Number 8. Christmas lights, the older type, often use this arrangement. Number 9. Adding more bulbs makes all bulbs dimmer. And number 10. Appliances in homes are connected this way. So let's check your answers. Number 1, the correct answer is series circuit. For number 2, number 3, and number 4, the correct answer is parallel circuit. Number 5, the correct answer is series. Number 6 is also series. 7 is parallel circuit. 8 and 9 are both series circuit. And number 10, the correct answer is parallel. And now let's wrap up our learnings. So we have here a table that differentiates the series and parallel circuit. For number of path, for series, there's only one path per current. And for parallel circuit, the electrons or the current has multiple paths. Next, if one device fails, in series circuit, all stop working. While in parallel circuit, others continue working. So next is application. Series circuit is mostly used in flashlights and old Christmas lights. And for parallel circuit, it is used in homes, school, offices, and vehicles. So parallel circuit is mostly used compared to series circuit. Next, the advantage of series circuit. It is simpler and cheaper. While for parallel circuit, it is safer and more reliable. And the disadvantage of series circuit. If one component fails, the whole circuit stops working. And for parallel, the installation is more complex and often more expensive. And now get your pen and your notebooks. It's time for assessment. Number 1. Which type of circuit has only one path for the flow of electric current? A. Parallel circuit, B. Series circuit, C. Combination circuit, or D. Open circuit. Number 2. In which current do the other bulbs remain lit even if one bulb burns out? A. Series circuit, B. Open circuit, C. Closed circuit, or D. Parallel circuit. Next, number 3. Which statement correctly describes a series circuit? A. It has multiple paths per current. B. Each component receives the full voltage. Letter C. If one component fails, the entire circuit stops working. Letter D. Each branch works independently. Number 4. Why are parallel circuits commonly used in homes? A. They use only one wire. B. All appliances turn off at the same time. C. Appliances can operate independently of one another. Or D. They have higher total resistance. Number 5. Which of the following is the main difference between a series and a parallel circuit? A. A series circuit has one path, while parallel circuit has multiple paths. B. A series circuit has multiple paths, while a parallel circuit has one path. C. Both circuits have only one path. Or D. Both circuits have multiple paths. And now for the answer key, let's check your answers. Number 1, the correct answer is letter B, series circuit. A series circuit has only one path for electric current to flow. All components are connected in a single loop. Number 2, the correct answer is letter D. In a parallel circuit, each component has its own branch. If one bulb burns out, electricity can still flow through the other branches, so the remaining bulbs stay lit. Number 3, correct answer is letter C. If one component fails, the entire circuit stops working. Since a series circuit has only one path per current, a broken component opens the circuit and stops the flow of electricity to all components. Number 4, correct answer is letter C. Appliances can operate independently of one another. Homes use parallel circuits because each appliance has its own path for electricity. This allows one appliance to be turned off or fail without affecting the others. And lastly, number 5, the correct answer is letter A. A series circuit has one path, while a parallel circuit has multiple paths. The main difference between the two circuits is the number of paths per electrical current. A series circuit has one path, while a parallel circuit has two or more paths, allowing devices to work independently. How did you do, class? Did you get a perfect score? Congratulations! And now for our ways forward. Using recycled materials, for example, cardboard, aluminum foil, batteries, bulbs, switches. Construct either a simple series circuit or parallel circuit and demonstrate how electricity flows through it. See you next lesson. Remember, life is brighter when we stay connected, support one another, and never stop moving forward. Thank you for your support. Please like and subscribe to Sir Dom's blog. Goodbye!